we're going to continue on the theme of ecosystem services now, and we're going to ask Professor Brendan Mackey to come up. Brendan, we're lucky to have you here at least for a few minutes. I know you've been running around. Brendan is a professor with the director of the Griffith University Climate Change Response Program. People probably know he's an IUCN council member, the regional councillor for Oceania. So, Brendan.
So I've got half an hour, right? That was a joke. I want to talk about two of the IACHI targets. 14, which relates to ecosystem services, and it mentions water, and 15, which mentions carbon. And I want to talk specifically about the role of forests, ecosystems, forest landscapes in helping to meet or address those two targets, and what might happen if we were to increase what would happen if we were to increase protected areas in forests in terms of addressing water and carbon, global goals of water and carbon. So, I'm trying to respond to Harvey's question, what would half do for carbon and water? Well, carbon's relatively easy because we've got pretty good numbers now. They could always be better, but they're not bad. They frame the kind of scale of the problem and the contribution that forests can make. So I'm not talking about offsetting fossil fuels. I'm not talking about fossil fuel emissions. I'm talking about the carbon that's stored in forest ecosystems, in the living and dead biomass in the soil. In fact, I'm ignoring the soil, which means I'm largely, I'm ignoring soil carbon, focusing on biomass carbon and actually living biomass carbon, but that's the stuff we've got some reasonable numbers for. And so what I want to ask is, how, and the critical thing we have to do now is avoid emitting greenhouse gases, okay? Like, that's the number one priority. We have to avoid emissions. So protecting forests is an avoided mitigation strategy. So if we have more natural forests in a protected area, we can argue we have more avoided emissions. So how much more could we possibly get? What's the maximum contribution protected forests could make to avoiding emissions of greenhouse gases? Well, we're used to thinking about the amount of carbon that's in the atmosphere in terms of a parts per million concentration, which is about 400 parts per million by volume, but that's a stock of carbon. And there's about 589 billion tonnes of carbon in the atmosphere at the moment. The total amount of carbon in terrestrial ecosystems, including the soil and dead biomass, is a lot bigger than that. It's about 2,500 billion tonnes of carbon, right? Like there's nearly 3 times more carbon in ecosystems than there is in the atmosphere. In biomass carbon, there's maybe about 550 billion tonnes of carbon, and in the living biomass, there's around 300 billion tonnes of carbon, and that's a conservative estimate. So it's been estimated, and this is done through global circulation modelling, if we were to completely succeed in deforesting the planet by 2100, atmospheric concentration of CO2 would increase by somewhere between 130 to 200 parts per million. They're the confidence intervals because it's a simulation modelling exercise. So that's the range. But remember your statistics, 290 is as likely to happen as 130. If we just look at primary forests, about a little over a third, about 37% of natural forest cover is primary forest. It's been unlogged. It's at its natural carbon carrying capacity. So it's about a fifth of that. So if we were to completely deforest primary forest by the end of this century, that would increase atmospheric CO2 concentrations by around 50 to 100 parts per million. And I said we're currently at 400 parts per million, and the upper limit of atmospheric concentration of CO2, that will give us a 66% probability of limiting global warming to 2 degrees above pre-industrial temperatures is about 450 parts per million. So if we were to completely stop all fossil fuel emissions tomorrow and allow deforestation continue, even if we just deforested primary forest, we would exceed the upper limit, the upper safe limit to achieve 2 degrees. And if we were to allow all forests to deforest, we would just, we would totally crash out 2 degrees. So you can argue that avoiding emissions by protecting forests at some level is actually an essential component of a comprehensive approach to addressing the climate change problem. Of course, we have to, avoiding emissions from forests doesn't solve the fossil fuel emission problem, but it's part of the total solution. I've got a minute to tell you about water. Water's much more complicated and it doesn't lend itself to a simple global accounting. The reason is there's a global water cycle, and and the planet's getting warmer, there's a more active water cycle, there's more water in the atmosphere, but the pattern of rainfall is changing. But if there's more rainfall somewhere, there's got to be less somewhere else. So the bottom line here is that what's important for water and ecosystem services is really the regional to local scale rather than the global scale. Global scale rainfall is driven by all these global scale processes to do with atmospheric circulation systems. But at the regional scale, whether you have an intact forest or not really affects regional rainfall. This has been shown for 30 years in the Amazon. It's called about a third of the rainfall that falls in the Amazon is from evaporation from the canopy in the rainfall. When you come down to a watershed level, it gets even more interesting. This is from a study done in Australia. The bottom axis is time after a complete destruction by fire or clear fell, and the vertical axis is how long it takes the water flow from the catchment to recover to pre-disturbance levels, and it's about 200 years. So what this graph is telling us in this watershed, this forested watershed in Australia, that it takes 200 years to get the flow of water out of the catchment that you had from a mature forest ecosystem. So the quality, if you like, of the ecosystem, its intactness, is really important in terms of the ecosystem service of water at a regional scale, bioregional scale, and a watershed scale. It's not so amenable to environmental accounting at the global scale. So, to conclude, if we were to achieve Harvey's goal of protecting half of nature, and that was a Archie target, we would make a very significant contribution to global mitigation targets, and we would also, depending on the local context, in parts of the world, make a significant contribution to regional rainfall stability, and in certain parts, in certain locations, a very important contribution to local water supply and quality. Thank you.